subscribed yet, make sure you kindly click on the subscription button so that whenever I upload a new video, you will be notified. Okay? So we are going to rush this down. Remember, we are concept based on order level mathematics. So today we are going to look at networks, and we are going to begin by understanding what a network is. Okay? A network simply consists of some properties or some concepts that we are going to use. A network consists of points. These points are called nodes or vertices. This is the first point. 2. It consists of lines, which could be what? Edges, arcs, and all of these are called what? Graphs. Okay? Now, when all of these things interconnect, they are going to form what? A network. In addition to what we call compartments, which are referred to as what? The different regions involved. Now, we are going to be understanding these properties in short. So let's consider a network below. Okay? If we have this as our network, now from this network, we can understand certain properties. The first one is what? The concept of nodes. As we have already seen, points or what? Vertices. From the network, we see that we have how many nodes? We have 4 nodes. Where are the nodes? This is the first node, the second node, the third node, and the fourth node. Okay, so these are the nodes involved in the network. They are just simply the points. Now, when you look at it from this point to this point, what we have is called an edge. These are edges. Okay, so this is the first edge, the second, the third, and the fourth. From one node to another node, we have an edge. Take note of that. So, if we are to talk about the edges or the arcs, how many of them are there? Remember, the nodes, we have 4 nodes. How many edges are there? We have 1, 2, 3, and 4. Now, talking about the regions. How many regions are involved? Remember, we said regions are the different compartments. Now, this is the first region. This is the first region. And now, remember, if we have a house, normally a house always has compartments like room 1, room 2, the toilet, the kitchen. Normally, we always have what we call the surrounding. And that is why we call this region, this network, a network with 2 regions. Because we always consider the outer environment as another region. So, this is region 1. And the outer region is called region 2. This implies that this network has 2 regions. Okay? To this effect, the GC board can come and they draw a network, a very simple network anyway, something like this, for example. And they start asking questions. How many nodes are there? We have how many nodes? 1, 2, 3. How many edges are there? We have 1, 2, 3. From this node to this node, 1, H1. This node to this node, H2. And this one, H3. So how many edges or arcs do we have? 3. How many regions do we have in this network? We have this, the first region, and the environment, which makes it 2 regions. This is an application, and this is how GC questions can be asked. So to this effect, we are going to look at how to draw a network. Okay? How to draw a network. Now, the GC board can come and give you data. For example, they can tell you that the number of regions or the number of regions in the network are 4, and the number of vertices or nodes are 4. You should draw a network that has what? 4 regions and 4 vertices. It is simple, and you can do this just by a trial and error method. I always advise students to use the circular method. That means you draw a circle. Okay? Well, I just want to try it together very fast. So we have, you can put your node here, your node here, your node here, and your node here. Those are the 4 nodes involved, or the 4 vertices. Now you see that one. How many regions are in this network? Just 1, just need to look for a possibility for us to have how many regions? 4 regions. So how do we do this? I can decide to remove one. I can decide to extend this network. I can remove this node, one node, and I involve it outside. I involve it outside. Now, how many regions do we have now? We have how many regions? 1, 2, 3 regions. We still need another region. So I can decide to disqualify this node and involve it here. I hope you see. Now, how many regions do we have? We have 1 region, 2, 3, and 4. And from drawing this network, we can ask you a question. How many arcs does this network have? How many arcs? We have 1, 2, 3, 4, 5, and 6. Another person may draw something different from this, but at the end of the day, this one another person will draw. Another person may draw something like this. For example, you see this network has how many nodes? 1, 2, 3, 4. How many regions? 1, 2, 3, and 4. Now let's look at the arcs. We have 1, 2, 3, 4, 5, and 6. The same thing. So irrespective of the diagram we draw, at the end of the day, you still have the same properties. Okay? So I want to look at the concept of odd and even nodes. Odd and even nodes. So I want to begin with odd nodes. An odd node is simply a node that has an odd number of lines linked to it. For example, this is an odd node. This will also be an odd node because we have an odd number of lines. This is 1, 1, 2, 3. You see that 3 lines linked to it. Since we have an odd number of lines linked to it, it makes it an odd node. What is an even node? An even node now means we have an even number of lines linked to that node. So, an even node could be something like this. 1, 2, so we have 2 lines linked to this node. It could also be something like this. We have 4 lines, 1, 2, 3, 4. So this is the concept of odd and even nodes. At this point, I want to look at what we call the Euler's formula. Euler. We're going to look at the Euler's formula. The Euler's formula simply says that if you take the number of edges, that the number of edges of every network is always equal to the number of vertices plus the number of regions minus a certain constant, which is 2. What is the application of this formula? They can tell you that the network has 25 vertices and let's say 10 regions. Then you find the number of edges. I'm not sure inside to draw and then count, but you see there are too many, so it will be difficult. So you can only apply Euler's formula. So automatically, so the number of edges will be equal to what? The vertices which are 25 plus the number of regions which are 10 minus 2. 25 plus 10, that's 25 minus 2, that gives us 33. So that network has 33 edges, and so on. I hope that is well assimilated. At this point, we are going to look at the principle. Now we are going to continue with the transmissibility of a network. Now, how do we know if a network is traversable or not? For a network to be traversable, it must have 2 odd nodes. Or all the nodes should be even. Okay? But now, if it has more than 2 odd nodes, it becomes non-traversable. So what do we mean? If we consider 2 networks below, let's consider these 2 networks. This is network A, and this is network B. Now, if you observe this network, you see that this network is traversable because all the nodes are even. Even nodes. But now this network is not traversable because it has more than 2 odd nodes already. This is the first odd node, the second odd node, the third odd node, the fourth odd node. When a network has more than 2 odd nodes, it is non-traversable. Okay? So this is the concept of traversability of a network. So a network can be traversable generally, is a general principle. If you can start from this point and trace through the network and come back to the starting point without repeating the certain node twice, then you can say that that network is traversable. That's another method too that you can use. But in summary, for a network to be traversable, you have two odd nodes, or all the nodes should be even. That's it. But if it has more than two odd nodes, it becomes not traversable. Okay? So that's the concept of traversability of a network. So let's take a glance at what we call network geometry. Network geometry. So network geometry is, in network geometry we are simply going to be talking about moving from one point to another with respect to direction. So let's consider the network geometry below. If we have, let's say we have a certain point A to a certain point B to another point C to another point D, for example. Now this network is said to be an undirected network. That means there are no directions. Now if I say that, if I start putting directions like this, okay, like this, and like this. Now what do you observe? This network is now said to be directed because it has arrows. So if we have a network like this, the first thing that we have to take note here is how we can move from one point to another. For example, if we want to move from the point A to the point C, how can we move from A to C? You see that it is possible for us to move from A to B first, and then B to C. Now, let's see, if we move from A to B, you see it is not possible for us to move from B to D and D because the arrow is pointing against our direction. That means it is not possible to move towards this direction because the arrow is going up. Is it okay? That means it is possible to move from B to C, but it is not possible to move from C to B. It is possible to move from D to C, but it is not possible to move from C to D because the arrow is against the direction. Okay, so take note of that. So the first point we should take note is the movement. So how many ways can we take to move from A to C? There is just one way to move from A to C. Remember, A should be the starting point and C should be the ending point. So we have A, B, and B, C. So the one way to move from A to B, A to C is what? The first one move from A to B, and then we then move from where? B to C. What about moving from D to A? Now, is it possible for us to move from D to A? How many ways are there for us to move from D to A? Let's say we start from D, yes, D to B. Now it's not possible for us to move from B to A. So you see that there is no possible way for us to move from D to A. That is all about network geometry. You have to take into consideration the direction of the arrow. If you're going this way, you see the arrow is pointing this way, that means it's possible for you to move from A to B. But since the arrow is pointing this way, it is not possible for you to move from B to A because the arrow is against. Is it understood? Okay, now there's what we call directed and undirected links. Now, you can be asked, the second one we have to take note is the number of links in this geometry. If you look at this network, you want to be asked how many links are at the point C. We have what? Links simply refers to the lines, okay? So we have this is the first line moving to C, and this is what? The other line moving to C. So there are two links at this point C. If you look at the point B, we have the first link and we have the second link. Now this other link is undirected because it is moving away from B. So take note. Okay? So now that is the concept of networks, and with respect to that, all you need to do is know how to tackle problems. For example, you can just come and draw a network like this. You draw a network like this. Now this is a network. So you can begin the network like this, and the first question will be for you to give the number of regions in this network. The number of regions in this network, how many regions? We have 1, 2, and the outer region, so there are 3 regions in this network. You can ask for the number of nodes. We also refer to node as the vertices also, or the points. So how many nodes are in this network? 1, 2, 3, 4, and 5. So we have 5. You can be asked for the number of arcs in this network, or the number of arcs is also referred to as the number of edges. So it refers to what? How many of them are there? We have first line, the second, the third, the fourth, the fifth, and the sixth. So we have 6 arcs in that network. And many other things. You can ask about the nodes. How many odd nodes are in that network? And how many even nodes are in this network? So look at this node is even because we have 2 lines at that point. This node 2 is even because we have an even number of lines at this point. This node is even. This node is even. And this node is even. So how many odd nodes are in this network? There is no odd node. So you can say that what the answer is 0. How many even nodes are there? 1, 2, 3, 4, 5. So there are 5 even nodes. And lastly, you can be asking this network is traversable or not. Due to the fact that this network has all the nodes to be even, it means that the network is traversable. You can be asked how many links, undirected links, are at this point. There are 2 and so on. So that's the concept of